All right. Well, welcome back. Like I said, the TU-X1 came along with that AU-X1, and I told you I probably wouldn't post very much on it unless we saw something worthwhile. And sure enough, I turned this thing on, and well, we have some problems with it. So problem number one is with the FM, and if you look over here. Okay, the first thing with the FM, if you turn it up,
the depth of amateurism, which is
you can see
is focused on. Really, if you want to make the NFL, NCAA football is the path.
when you tune it right on center like that, you can see the meter's not centered, and we are selecting signal meter for the tuning over here. I'm sorry, the signal meter's there, but this is your tuner centering. So that tells us right now that obviously we have a problem with the discriminators not aligned. That could be a simple alignment, but worse yet is the AM. When we go to AM, turn the volume up all the way, there is absolutely nothing. The AM is dead. So we got some work to do on this one. So this will just be a troubleshooting video. We're not going to go through the whole restoration and everything on this. You saw that. I have another video on one of these. We're just going to do the troubleshooting. So if that sounds interesting to you, stay tuned, and that's what we'll be doing. Well, there's the problem with the AM. You can see when I turn the tuning knob, nothing happens, and it's because this coupler is cracked. But not to worry. We're just going to replace them with these. I keep a couple spares of these. They're not cheap, but I have two left, so I'm going to do the top one and the bottom one when I replace it. I think that's probably all that's wrong. We're going to test it out and make sure. Okay, we're not going to be lucky this time. I can turn this wherever I want. I have the volume all wide open and nothing. Every now and then I'll get a little bit of static, like it crackly, like a transistor that's going in and out, but other than that, it is dead. And I can switch between FM and AM. If I go between the FM and AM, you can hear the FM comes right to life when I switch it in, but the AM, not so much. So, and like I said, it doesn't really respond to anything, so I have a feeling there's a component failing on this board. So we'll look and see, and when I get an idea of what's going on, I'll be back. Okay, this one's a hard one. So I'm scoping right now the output of the RF amplifier at the front end, and using an oscilloscope. This isn't the best way of looking at it, but this is after the amplifier, and you can see it is just going insane. And every now and then I'll get snap, crackle, and pop like there's something shorting out. It doesn't seem to be a transistor, and it doesn't seem to respond to heat or cold. It could be an integrated circuit. There's an LM1496. It's like a little RF amplifier that takes place after the first FET amplifier in the RF stage. And that's what we're looking at the output right now. And you can see how bad that is. Now, if I move the probe over to the kind of roughly where the output of that FET is, it's not real stable either, but that could possibly be because of my probe being on there. And there goes the noise. You hear it? And every now and then it'll just randomly do that. But you can see right there the amplitude just going crazy on this thing. And I can somewhat tune it. You can see I can pass through the tuning. And it's on the tuning capacitor roughly where I would expect it, because I have a 1 megahertz signal going in. But if I go all the way to the end, sometimes this thing will just, see, there it goes. See what it's doing? And then this will just, now see, that's not even modulated, and I have a modulated signal going in there. There we go. There's your modulation. And you can just hear it doing that every now and then. But there's all kind of craziness in here, so I am just not sure where this problem is. So we're going to have to keep digging. Okay, so now we're getting somewhere. I'm feeding just a 1 megahertz sine wave only, just a RF carrier into the receiver, right into the antenna jack, as you can see. However, when I measure the output of the local oscillator, let me show you what it's giving me. So if you look and see, I'm very precariously holding this. There's what your local oscillator is doing. And if you notice, it's 1.434 megahertz. Now, what's the problem with that? I've just taken the probe off so it's holding the last reading. Well, in this receiver, as in many AM receivers, your IF frequency, or your intermediate frequency, is 455 kilohertz. So what that means is that your local oscillator is always going to run, or at least in most typical cases, is going to run 455 kilohertz above whatever your tuning frequency is. So if you're tuning a station to 1,000 kilohertz, then your local oscillator is going to be running at 1,455 kilohertz. But if you look in this case, the local oscillator is running at 1,434 kilohertz. It's way off. So obviously the thing's out of alignment, but my big question is, how can it be out of alignment? It doesn't really look like anybody has tried to ever take this apart or service it. So the first thing we're going to do is try to just adjust it to see if it comes in. But if it's out and it's just an adjustment, then our next question is going to be, why did it move? Things just don't move on their own. Something must change in order for that frequency to change like that. So it could be because of a component that has drifted in value. It could be that somebody did try to do an alignment on it and didn't have the proper test equipment. I don't know. But the first thing to do is go in and see if we can bring this back to 455 kilohertz above your RF tuning frequency. That way, if our local oscillator is working properly, then we can move on to the rest of the circuitry. But if your IF is being generated at the wrong frequency, everything after it pretty much doesn't matter, because you're never getting to the point where the rest of that circuitry is going to be able to do its job. So let's see what we can find out with that. Okay, well, as you can see, I'm on test point 12, and one of the things we have to do is it's kind of tied in to your PLL circuit, and the idea is we have to get TP12 to sit at about 455 kilohertz. It is currently sitting at 589 kilohertz. This transformer, which is T04, I believe, when I found it, it was backed all the way out and kind of jammed in there. I don't know if that's factory or what, but rotating it back in clockwise actually was bringing the frequency closer to 455, and I was actually starting to hear a tiny little bit of radio hiss coming in, but it nowhere near brought it to 455. So we have a problem, and of course, Murphy's Law, the transistors, the whole oscillating circuit for that is under this metal case. And in order to get to the metal case, you have to desolder it, and in order to do that, you have to remove the board. And I can tell you right now, even though this looks like there's a couple of screws, I know I made a comment on the first video I did on this because I spoke too soon, but I soon found out after I made that comment on the last one that this thing is a real pain in the butt to take apart. And not because, really easy to take this pan out, this chassis, but the problem is they solder wires on the rear of the board. They're tighter than banjo strings, and they're really hard to get apart, and a lot of them are not on connectors. So getting everything down to the point where you could take these out is really a lot of work. So in order to just take the couple little tabs off of this to be able to make some measurements, which might not be the problem when we find out, I got to tear all this stuff apart. So yeah, you know, famous last words when somebody turns something in and says, oh, it works perfectly, just needs gone over and check the alignment and maybe you do a recap. Anytime somebody says that, guys, get ready for the big job. So, all right, well, when I find out what it is in here, I'll be back. Okay, I went through all the hassle and took everything apart. And right here, there used to be a capacitor that I just removed. And I will show you why I removed it. Because when I pulled this little metal cover off of here, right there's what was in it. Look familiar? Go back to my last video on the TU-X1. Yes, it's one of those black film capacitors. It's 47 picofarads. But when we put it on the Sansui, lo and behold, it is reading 1.9 picofarads. Yes, that cap is open. And that is why it's probably not working. I think we found the problem. So there are two more of them on this board, right here and here. And obviously I am going to replace those. And once I do, we'll be back. I've got this whole thing tore out, and I am going to recap it while I got it apart. That's what the owner wants, the electrolytics replaced, so we're going to do it. And we're going to put this all back together and really cross our fingers. And I'm thinking that's what was wrong. Okay, we're all back together. And as you can see, I got everything connected back up. I have the probe back on TP12, and look how close we are. Lot better than 589. So we're pretty close right now. And if you listen, and you can hear. Yep, it's working perfectly. So all we have to do is dial it in now, and everything should be good. And when we adjust this now down here, I'll kind of show you a little bit. We can see if I go the right way. There we go, right on. Okay, all fixed. And while I was in there, I recapped the power supply down here, and got some of the, yeah, down here, and I got some of that kind of stuff done. I recapped this board. But amazing what one little tiny capacitor can do. All right, everything's all tidied up and put back together, and so let's turn it around here a little bit and see if we can get some stations. Okay, just a quick thought I'd share this with you. This is the underneath of the FM tuner pan, which is that chassis that's removable. They make it really nice to remove, but then all these wires are soldered in on both ends, and they're all going through all of these little loops, and you have to kind of work around. This board's not that bad to recap, but this one here, it's right up there with, you know, if a proctologist tried to do a root canal. That's kind of what it feels like doing this. But anyway, you kind of have to tie the wires back out of the way as you work, but you then be patient, and it really helps to have a soldering iron with a really short heating element. The ones with the longer, wider heating elements are going to really make it easy for you to touch one of these wires and melt the coating, melt the insulation on the wires. So you just have to take your time and be careful. But it's all done now. This thing's all recapped and finished. And I'm going to put it all back together and do a quick alignment on the FM. I have a feeling, I mean, the FM was perfect when this thing came in, so I doubt that there's much going to need changed on the alignment on it. And then once we get it together, I'll show you what our plan is with this receiver, with this tuner. This is a request by the owner, and so that's really what this video is going to be about. This first part was just getting it repaired and getting it up to standard so that we can do what we're going to do with it. Okay, we're all back together. Everything is working perfectly. The alignment is spot on. And, you know, for any of you that are kind of new to the tuner thing, if you're working on tuners, this is absolutely not a tuner you want to start out with alignments. They talk about a device called a genoscope. It was very common back in that time. Genoscopes are actually capable of, kind of like my SG-165, they can actually produce a swept signal with markers, and you have to use a detector probe, and you have to look at the markers and look at the waveform. It's not a really easy thing to do if you've never done one before. There are alternate methods of doing alignment on this tuner, but it's really not something you want to do unless you really understand how these work. But anyway, they're fantastic tuner. So now what we're going to do is we're going to get to the interesting part of this video. This is actually part 2 of this video. This is a request by the owner. He really wanted me to do this, so I agreed that, kind of after a little arm twisting, to go ahead and do it. So we're going to see if we can get this to work. I don't even know if it's going to work, but we're going to try it. And who knows? We'll see where this goes. But let me show you what we're talking about. All right, so right here is what we want to do a little bit different with this tuner. What this is, if you've not ever seen or heard of one, this is called a Meducci stereo AM adapter. Meducci, it's made by, and you can look it up on I think it's MEDUCHI or MEDUCCI. I'm pretty sure. I'll post it up there on the comments here during the video. But essentially what this does is it takes the IFs, you tap into the IF circuit of an AM radio, and it picks off that IF, and it will demodulate an AM stereo station. And believe it or not, AM stereo was a thing at one time, and in some ways it still is. There are a few channels out there that still broadcast in AM stereo. Now this one uses there were different ones experimented with, and really the one that's became the most popular, at least here in the States, was by Motorola, and it's called c-quam, C-QUAM. And the c-quam, we'll get a little more into how that works later. But this little company made these little adapter boards, and in some instances, if your tuner has the right specs, you can actually do this. Now, one of the things that interested the owner in this product was the very fact that back when Sansui was building the TU-X1, they actually were anticipating AM stereo, but clear back in 1978. And AM stereo goes back way before that even. So what they did was, on the rear of the TU-X1, they actually put a little RCA phono jack, and it's an output tapped into the IF section of the AM tuner of that TU-X1. And what it was that you would be able to connect a little connector RCA plug to that and go into an external box that would be able to decode AM stereo. So what we're going to try to do is see if there is some way we can modify the TU-X1 to utilize this. Now there's one thing that, I guess it's just the way I am about it, I absolutely refuse to install this in something like this TU-X1, being the fact that the TU-X1 is so rare, so valuable, and it's such a high-end tuner. I'm not into doing things like that. Different people have different feelings on that, but as far as I'm concerned, if I'm going to be passing, maybe if this was my own unit, possibly, but if this is going to be passed on to someone else who's a collector of this vintage classic gear, I don't want to ruin it in any way, shape, or form. So whatever we do to install this, it has to be 100% reversible and the least invasive possible. I don't want to modify circuitry. I don't want to cut things. I don't want to unsolder parts from boards. Nothing like that. I don't want to build things. It has to fit. So what I'm going to do is I'm going to look at the schematics. I'm going to look at what we have. We're going to look at some of what the requirements of this thing is, and then we're going to determine whether this will actually work or not. Okay, so here's our attempt at what we've come up with. Here's the Meducci board installed, and again, my first rule, it must be reversible and it must be non-invasive. I don't want to make any changes that can't be put back to factory original. So here's what we did. We'll take a look at the schematic here in a second. I did break the rule very, very slightly. I made one 2.5 millimeter hole in this little shield cover, which is this little cover actually comes off 2 screws. And there's one little hole right here for this mounting screw. That is the only modification to the entire thing that I made. If you look right here, this worked out perfectly. If you look on here, this connector right here, let's zoom in a little bit so you can see more what I'm talking about. There, how's that? A little better. So this right here is the wire that goes out to this back plug right here, this RCA connector. And this RCA connector is that AM/IF out for stereo. So what we did was we took a shielded cable, and I just took a regular shielded cable, attached it to the input of the board, and connected it right over there, and you can see what a short run that is. So that's perfect for this. So that's the input to the board. We then powered it with your negative and your positive here, and I'm just picking off the plus 13 volts off of the main power supply. So this actually right here, I'll just show you. It actually comes down along this little bundle right here. Let me back it out a little bit. Comes down along here. I put this little strain relief in using one of these 3 existing holes. You can see there's 2 left. Have this one here, so didn't drill anything here. Come across here and right onto the bundle down here, and then right onto right here's your plus 13 and ground, and all of the pluses and minuses go right down to that same area down there. So that was real simple. I then came off with my 8 volts, which is the 8 volts regulated on the board from this little 8 volt regulator, and the drive signal for it, which this is an active low signal. So this blue wire and this yellow wire both come and they go down around here, and they actually go up in the front, like up front here into the dial indication. And what I did basically is right where the panel lamp is that lights up the 2 meters, you have your indicator lights for stereo and wide and AM and FM and all that. Well, there's an open area right over there, and I'll show you in a minute, where the edge of the AM tuning meter is. And what I did was I mounted a high brightness blue LED right there, so that in theory, if this thing goes into stereo, that blue LED should turn the tuning meter for the AM blue. So when the AM turns from a soft white color to a blue color, you know that you've tuned in an AM stereo station. At least in theory, that's what we're hoping for. Now we have these 2 output wires here, and they're shielded, and they follow the same path, and they come down and they plug into the board right here. And you can see the plug that was there, I just have removed, and it's just zip tied off to the side here. So we can just plug that right back in. So really, to remove this entire thing from the circuit altogether, all you really need to do is unplug this connector and plug this one in, and everything's back to factory original. Take the one screw out, pull the wires out, it'll be like this thing was never in here. So let's talk a little, well, let's first of all see if it works. We'll flip it around, and then we will go ahead and talk a little bit about how the thing works, if it works. Okay, the thing's all back together. We are in the dark. You can see we're all turned on. And what I want you to do is I'm going to turn this up. And right now I have a carrier signal turned on. And I'm going to show you how I'm doing this here in a minute. But I just want to demonstrate the function of this thing first. But we have a carrier signal, and we do have the pilot turned on. So if this stereo device works, you should see the tuning meter right here, the AM tuning center, should turn blue. And that's if we have lock on a stereo station. So let's turn this up. And right now the carrier signal is set at about 1250 AM, 1250 kilohertz, which is 1.25 megahertz. All right, so tuning down the dial. When we get down around in this area somewhere with the dial, we should see it lock. You can hear it gets quiet. And let's see here, am I on a station? Right there. And look at that. Bright blue. And sorry guys, but I can't turn this on for very long. I'll turn the microphone. Let me move the microphone over to stereo here. And we're going to play something for about maybe 5 seconds, and hopefully I won't get flagged on that. Okay, I really hope this works. So turning it on, and again, we're only going to do 5 seconds of this or so. I hope you heard that. And I'm sure you guys know what song that is. I can assure you here in real life, hold on a second. Okay, as I was saying, I'm sure you could tell what song that was, and I can assure you that it was very, very much stereo. And believe it or not, when it's locked in on a stereo station like this, it does sound surprisingly good. It has a very wide separation. The high frequencies are surprising. I mean, compared to today's FM stereo, which is really subpar compared to what used to be out there in the 70s and 80s, it actually sounds pretty good. Now, there's one thing that if you notice, I don't know if you noticed, but one of the things they gave us with this thing is a crystal filter. And one of the problems with AM stereo is the pilot tone for AM stereo, for c-quam, is 25 hertz. Now, if you recall, on FM, it's 19 kilohertz. And when we cut off all of the high frequencies above 15 kilohertz, that means there's no way that you can hear the carrier tone. On some of these really high fidelity AM receivers, like this one and like that DIMEC that we worked on earlier, they're capable of going down to 25 hertz or even 20 hertz. So without that filter in there, it is possible sometimes during a really quiet passage to just barely hear the pilot tone. Now, the pilot tone does not sound like a rumbly 25 hertz signal, but it just kind of sounds like a little pulsating buzz. If you put that filter in there, it will, of course, decrease the fidelity of the system, which is kind of weird being that you're looking for high fidelity stereo. But it does get rid of that little bit of background. It's not that annoying, and it wouldn't bother me at all, because AM static is a lot louder than that little pilot tone is anyway. Now, the other thing you need to know about this is you really have to have a strong signal. I don't know if you can see where the meter is right here, but I am almost pegged at 100%. It's just about at 90. And it takes that much of a signal to really get a good stereo signal. It's just like FM stereo. If to get a multiplex signal to trigger, you have to have a really strong FM station or it really gets staticky and poor. AM c-quam is the same thing. So if you don't have, you basically need an AM station that you could pick up with the fillings of your teeth. If you don't have that strong of a signal, you're not going to be able to do this, and you're never going to see this blue light come on. But, with the test environment in here, I'm feeding it a strong signal just to prove that it works. Again, if I have my closest station that is AM stereo, and believe it or not, there are quite a few out there. I didn't realize it. Is AM 1330. It's about 100 miles away, and unfortunately, even with my outside antenna, I am not able to bring it in enough to get AM stereo, and they only broadcast in stereo during the daytime anyway. So let's take a look at how I was able to get this whole thing to work on the bench. Okay, what you're looking at is a gizmo that actually takes a standard line level input like this from my digital music player, and it transmits it and turns it into an AM c-quam capable stereo broadcast. This little box there, this little board is actually compliments of a company or a gentleman by the name of Chris Cuff, and he has a little website called amstereoguy.com, and I'll try to put these things down in the show more section under the underneath the video, so look down below. And he's really into AM c-quam stereo, has a whole bunch of products on there. I don't know how much he's still selling or anything like that. This was kind of like one of his last ones that he had in stock. He used to have these in kit form where you could buy them and assemble them yourself. And essentially what you do is you attach a little battery pack to it. So just use a little AA battery pack. You connect it up like this. You see it light up. And we're broadcasting AM stereo right now. That's all there is to it. Couple of little pots. You have your input trimmers for your input level. You have your 25 hertz pilot tone centering, and you have your RF output. And this RF output's very critical to your tuner. Now, again, this is a very low output device, and you have to be in the right circumstance. Down here on my bench, I really need to actually just connect this directly to the antenna jack of my receiver to get the signal to be strong enough. And the funny thing is, if I move the wire around the room, obviously I can hit little peaks and troughs where it will tune in perfectly, on the aerial. But really, with all the junk on the bench and all the computers and things down here, it's really difficult to get it to work. But proof of concept. This works very well, and obviously the Meducci decoder works really well also. I think Chris over at AM Stereo Guy also makes his own version that's very similar of an c-quam stereo decoder. I don't know if he sells them on eBay or not, but that Meducci kit, and again, I'll put a link to that down there too. You can actually buy those still online on eBay. They're very inexpensive, by the way, too. They don't cost that much. So there it is. That's how you do it. And as you can see, it worked really well. So here's a little schematic of the Meducci board itself. It's really a pretty simple circuit. There's not much to it. And I do have an extra one of these, and you can see here's that little ceramic filter that it comes with. It's just held on there with a piece of tape right now. But the idea is to remove this. This will cut out that pilot tone if you need it. I'm not going to, like I said, I am not modifying this receiver at all. So we're not going to do any of that. But, and like I said, it's not that annoying. It doesn't really bother me a whole lot. You can't really notice it unless it's a very quiet passage in the music. And again, you know, these are readily available online, and relatively few connections. You really have your right and left. You have your 12 volts DC input. And this can be anywhere from 8 to actually upwards of 20 volts. It'll work just fine. Your IF in, and choosing the IF on this in a receiver is the name of the game on this whole thing to get it to work. You have your ground, your stereo indicator light, and notice this whole circuit you kind of have to add yourself if you want to do forced mono. You can actually put a stereo mono switch. I did not put that in, but if you don't, you actually have to connect the other end of the LED to the plus 8 volts, which is right here. See it? And that is not, there is no connection for that. You have to make that yourself and run an extra wire. Let's see, another thing. Hold on. So looking on the schematic here, hold on a second. You can see your input here. You have your RF amplifier, you have your mixer, you have your, this is your filter, you know, your low pass or your band pass filter. You have all the rest of your IF, and if you look up here, here's where they're picking off that IF signal right there, and that's just before the AGC comes in. So then you come out of here and then you go loop back through your AGC circuit and around. You have your local oscillator, your PLL, all of that is there. What we are carving out of the circuit by connecting this is essentially the detection end of it over here, which you don't need with that Meducci. And actually the Meducci, that little Motorola chip, does a fantastic job, even for mono AM. So where are we disconnecting this? Well, right here is your audio section. After the IF gets detected, so you strip your audio off of your carrier, your 455, so you no longer have the 455 carrier IF, you just have the audio. It actually goes out, and then it comes back through these two wires here, which goes into this dual amplifier. Believe it or not, this is a mono AM section, but it actually has a stereo amplifier right and left. And you can see here's the relay that switches the AM in and out. So when this comes in, there's another similar relay to this on the FM side that'll drop out, and this one will come in when you switch between AM and FM. And this will actually amplify your signal, and it passes it on through here, and that's what goes out to your switches and everything that goes out to your jacks on the rear of the tuner. So all I did was I unplugged the connector. There's a connector right here on this pin 24 and 26. I disconnected that, and I plugged in the output of the Meducci right into here. So that's what you were seeing, that connector I plugged in. So really almost all of the circuitry, with the exception of some of the detection circuit, is still being used. So you know, so really you still get the advantage of the phased lock loop IF and all that and so forth. And that's why it works so well. What I will tell you, it is a total bear to get this thing to, if the alignment is even off by the tiniest little amount, none of this will work. You'll get all kind of birdies, and it won't lock, and the signal meter will be bouncing around. It won't center. So you really have to have some good test equipment, and you have to be very patient and go through and make sure that that IF alignment is done absolutely spot on perfect. And honestly, if you follow the instructions, you'll get it close, but you really got to kind of hand tune it by ear, and you have to kind of follow along and you know, till you get everything to fall into place. It's a little bit less of a science and a little bit more of an art, if you want to kind of word it that way. But if you get it tuned in, it works perfect. And like I said, I was really surprised with the amount of stereo separation this gives. You know, you get, it's like FM stereo, very similar. You don't get hardly any sibilance or anything like that like I really expected. But again, you better have a strong signal. Like I said earlier, that signal better be strong enough to pick up with the fillings of your teeth. So I'm just kidding, but you know what I mean. So anyway, that ends this little project. And this special tuner now is even more special because it can actually, it's started out all those years ago to be ready for the future for AM stereo. And here it is all these years later. It's a reality. So you get the awesome FM section, the awesome AM tuning, and now it even can do AM c-quam stereo. So I hope you like this little video. I know that I'm probably going to get a bazillion questions about all this, and that's fine. All the contact is down there. You know, we'll see what we can answer as we have time. But if you're really interested in the AM stereo stuff, let me know. Maybe we'll do a little follow-up video or do a little bit more on it. Again, I'm probably going to do the DIMEC, the McKay DIMEC tuner. I'm going to add the Meducci to that. It actually is set to accommodate that specific board, so it'll be a real easy upgrade on that. Other than that, this thing's perfect. It works great. It's all recapped. It's realigned. All the lights have been converted to LED, and we now have another married couple, don't we? The TU-X1 and the AU-X1. So whoever ends up with this pair is going to have a really special setup. So that's awesome. I wish I could have this one. This one would be front and center in my living room, I think, if I owned it. But anyway, again, I hope you all enjoyed the little video, and I wish you all peace, joy, happiness, and good health in your lives. And till next time, we'll see you soon, and stay well. A lot of more things coming up. I'm behind. You know, work has been just super crazy busy, and you notice it's been a little bit less frequent with the videos, and it's probably going to continue that way for a little while till we get on top of things. But anyway, thank you all. Have a great day. Thanks for everything. Thank you for your donations, for your good comments, and so forth. And stay tuned. More to come. Bye-bye.